A student council service project involves shopping for, preparing, and serving a meal at an urban homeless shelter and cleaning up afterwards. The director of the shelter provides volunteers organizations with a chart with the number of hours and the number of volunteers for each meal. Use the values in the chart to create a scatter plot and to write a function that will help the student council determine how many student volunteers are needed if the time each student should devote to the project is 2 hours, 2.5 hours, or 4 hours. Okay, so first let's go ahead and use the values to create a scatter plot. And so in our calculator, go to the Stat menu and then press Enter on one edit. And so in list 1, let's go ahead and put the number of students. So just putting in the value and then pressing Enter to go to the next row, I've gone ahead and I've put in all of our values for the number of students. And then in L2, let's put in the number of hours, going in order and then pressing Enter between each one. You can double check here and just make sure that the right number of students, 70, goes with the right number of hours, 1 and 2500s, and so on, because sometimes students reverse these. So making sure that they're all going together, let's go ahead and go to our second stat plot. And we're going to turn our plot 1 on by pressing Enter, then Enter on, and we have a scatter plot. And then here we're going to have our X values be our L1, which was our number of students, and our Y values be our L2. And so let's go ahead and look at our graph. And so we don't have a window we can see very well. Let's go to our window. And since our X values or the number of students are between 0 and 70, I'll just go between 0 and 75. And then our Y values, notice they don't go lower than about 1. So I'll just have it go from 0 and then all the way up to 9.5, since it goes all the way up to 8 and 7500ths. Now press graph again. And so here we have a curve, and it looks like it could be a rational function, since as the number of students goes up, then the number of hours goes down. It has that inverse relationship. And so if we just check our products, if those are approximately the same, then this would be a rational function. So let's go ahead and check that. And so now let's find the products of S. We'll just call the number of students S, and then the number of hours H. So first, 10 times 8 and 7500ths, that just gives us 87 and 5/10. 20 times 4 and 2500ths, that gives us 85 even. 30 times 3 is 90, and so on. Let's go ahead and find the rest of these. Okay, and so these are pretty similar. Quite a few of them are actually the same. And so a rational function model would be a good idea here. So let's go ahead and just add up together each of these products of S and H. And we'll go ahead and add those and then divide it by 7, since that's the number that there are. Then we get 617 and 5/10 divided by 7 gives us 88.214285, etc. And so let's go ahead and round to the hundredths, so 88 and 2100ths. And so then if we use the number of hours as our dependent variable, then we could say H of S equals 88 and 2100ths divided by S. And so now to check and see if our function model is very accurate, let's go ahead and go to our Y equals and put in our H of S function, but this time using X instead of S. And so now press graph, and we see this is a very good function because it's going through or very, very close to all of our data points. And so let's keep going. And so now to answer the question for how many students for 2 hours, 2.5 hours, or 4 hours, then note that with rational functions, we could rewrite that. If you solve for S here, you can multiply up the S and divide by H of S to solve for S. And so it actually is the same function, just switching the variables. And so I just wanted to show that because if we want to plug in the hours, which is our H of S, then we could just go ahead and plug that in there in the bottom, and that's going to be our same answer. And so plugging in 4 hours, then we would just plug in that in our denominator. So 88 and 2100ths divided by 4, and that gives us approximately 22 students, since students need to be a whole number there. So now let's go ahead and find for 2.5 hours. So dividing by 2.5, then we get approximately 35 students. For 2 hours, we get approximately 44 students. And so there's each of our estimations for how many students with each of these numbers of hours. And then we can compare these values by finding linear models also for each of these 2 hours, 2.5 hours, and 4 hours. And so the way that we'd find a linear model is for 4 hours, we just need to see, well, H, 4 hours would be in between 4 and 2500ths and 3, and 20 and 30 students. And so we can find the average rate of change there, and then use point slope form to actually find a linear function. And then for 2.5 hours, it's actually going to be taking the average rate of change of the next two to the right there, 3 and 2 and 25 hundredths, and then 30 and 40. So we'll do that same thing and then the same again for 2 hours using point slope afterward to actually find our equation. And so starting with 4 hours, then let's find that average rate of change. So taking 3 minus 4 and 25 hundredths divided by 30 minus 20, then we get negative 1 and 25 hundredths divided by 10. So that gives us negative 125 thousandths. And so that will be our rate in our function. So we'd have h of s equals negative 125 thousandths s, and then plus our y-intercept. And since we don't know that, then we can go ahead and plug in one of the endpoints there into our point slope form. So we'd have h of s minus, and then the y value, let's go ahead and pick 3, and equals negative 125 thousandths times s minus, and then the corresponding s value, 30. And so multiplying that out, we get negative 125 thousandths s, and then plus 3 and 75 hundredths equals h of s minus 3. So then to solve for h of s, just add 3 on each side. And so we get h of s is equal to 25 thousandths s plus 6 and 75 hundredths. And so now we want to know if the time is 4 hours. So we can go ahead and plug in 4 for h of s and then solve for s. And so now solving for s, we can go ahead and subtract 6 and 75 hundredths on each side. And so then we get negative 2 and 75 hundredths equals negative 125 thousandths s. Then dividing by negative 125 thousandths, then we get 22. And that's the approximate number we got in our rational function. So then using that exact same process, but for 2.5 hours, for our ratio, I went ahead and used 2 and 25 hundredths and 3 on the top, took the difference of those, and then the difference of 40 and 30 on the bottom. And using that, I got a rate of negative 75 thousandths, and then using point slope form, I was able to get this equation, and solving it for s, I got approximately 36. For 2 hours, using that same process, I won't go through all of the steps again, but using the exact same steps we did here on the left, then we get this equation, and solving that, then we get s is approximately 45. And so you see here that it's a little bit higher in our linear function model for 2 hours and a little bit higher for 2.5 hours. But it's still really close, and so these are reasonable answers. So we have gone ahead and answered all these questions. Let's go ahead and summarize.